So you're ready to jump into machine learning, huh? That's awesome. There's a ton to explore. It can definitely feel a little overwhelming at first, so many tools, so much jargon, but that's what we're here for, right? To break it all down, you sent over that great piece on medium machine learning tools or concepts. Where to start? Part 2 by Mohammed El-Rafi. Really interesting stuff, and I've got our expert here to help us unpack it all.
Choosing to really get those concepts down before diving into the tools is a great place to start.
Yeah, he really hits on that, doesn't he? The article stresses how important it is to have that strong math background
Right.
before you panic and think you need to be like a calculus whiz.
Right,
You
exactly.
don't,
Yeah.
at least not right away.
El Rafay nails it. You don't have to be a math genius or anything, but understanding the fundamentals, that's key. It's like, it's like having a good set of tools,
Yeah.
right?
Yeah. Okay.
Yeah, you might not need every single tool for every job, but having them there, knowing how to use them,
Hmm.
it means you can take on a wider range of projects. You're more confident.
Love the analogy. So true. So instead of getting lost in complex equations right off the bat, it's more about grasping those core mathematical principles, which the article does a great job of laying out. And this is where it gets even cooler, I think. He shifts gears from the theoretical to like the hands-on stuff,
Yeah.
data science, and how crucial it is in machine learning.
That practical application is so important. It's like the bridge between those math principles and actually building something real.
Totally. And he breaks it down into these manageable steps, right?
Mhm.
Data collection, analysis, processing. It's like he's mapped out the whole journey. What I found really interesting was this idea of it being iterative. It's not just a straight line from A to B, is it?
No, not at all. It's a constant cycle, refine, adjust, refine, adjust. You have a goal in mind, but you're always molding and shaping as you go.
I like that. Molding and shaping. And speaking of the data itself, I'm curious. Does the type of machine learning you're into, does that change which data science techniques you'd use?
Oh, absolutely. It's fundamental. Think of it like choosing your material. Are you drawn to image recognition, working with all that visual data? Or maybe you're fascinated by language processing, all about the text.
So the area you're interested in that really shapes the entire landscape of your machine learning journey.
It's the foundation.
Wow. This is already making those initial steps feel a lot less daunting. And, El Rafe doesn't just leave us hanging with the theory, right? He gets into the actual doing, the programming languages,
Hmm.
specifically Python.
Yeah, Python has become like the language for machine learning these days, and for good reason.
For sure.
It's pretty beginner friendly syntax, which is huge when you're just getting started. But, don't let that fool you. It's incredibly powerful under the hood.
Definitely not a toy. He even calls out, let me see, yeah, SciPy and scikit-learn, these Python libraries. I'll admit those names sound kind of intimidating at first, like, oh, great, more to learn.
It's like anything else, right? You hear the names and it's like, whoa.
Exactly.
But they're actually there to make our lives easier. It's all about working smarter, not harder.
Okay, so break that down for me. How do they make things easier?
Think of them like, pre-built modules for all sorts of common machine learning tasks. So, say you're working on image recognition. Instead of writing every single line of code from scratch to process those images, analyze them. You can use a library like scikit-learn. It's got ready-made functions, algorithms, all that, to handle those tasks efficiently, accurately.
So instead of reinventing the wheel every single time,
Exactly.
you can focus on the big picture.
Yes. And frankly, it frees up your brain to really understand what you're doing, the concepts behind it all.
I like that. Working smarter, not harder.
Uh,
You mentioned image recognition. What are some other examples where these libraries come in handy?
Oh gosh, practically everywhere. You've got libraries for natural language processing, for working with huge data sets, for building different types of machine learning models. You name it, there's probably a library for it.
It likes having a massive toolkit at your disposal.
Exactly. And the best part, most of them are open source, meaning they're free to use and constantly being improved by a global community of developers. It's amazing when you think about all this power right at your fingertips.
Amazing is right. And speaking of amazing, El Rafay kind of leaves us hanging at the end here. He hints at what's coming next. Linear and logistic regression.
Ah, yes, the heart of prediction.
He says they're key techniques used across all these different industries. Before we get into the nitty-gritty, can you give us a taste of what these regressions do? What are we even talking about when we say regression in this context?
Well, at their core, regressions are about uncovering those hidden relationships within data, like finding the secret connections that let us make predictions. It's like, you see a magician make something disappear.
Yeah.
Regression analysis is like figuring out the trick, how it all works.
I like that. uncovering the magic in the data. So we've got Python, data science. It's all been leading up to this, right? Regression analysis. I got to be honest, that term always throws me off a bit. Regression, like we're going backwards somehow.
Yeah, I get that. It's a little counterintuitive.
Sure.
But regression in this sense, it's all about finding the relationships in your data, the connections. That's how we make predictions.
Okay, so let's talk about those predictions. You mentioned customer churn earlier. What else can we predict with this? LREFA focuses on two main types, right? Linear and logistic.
Let's start with linear regression. It's often used when you're trying to predict a numerical value, something on a continuous scale.
Okay, so like not a yes or no, but a...
Exactly, not a category. Think back to that housing price example.
Oh, right. That was a good one. Felt very concrete, in a sea of abstract concepts.
Absolutely. Say you're a real estate agent, you're trying to figure out the best listing price for a house. Linear regression can look at all that historical data, square footage, location, recent sales in the area, and predict the optimal price for that specific property.
It's like finding the trend line, right?
Mhm.
The one that best fits all those data points. Gives you, hopefully, a more accurate prediction than just going with your gut.
Exactly. You're on the money.
And logistic regression, when would you use that instead of the linear kind?
So logistic regression, that comes in when we're dealing with categorical outcomes, not a continuous scale, but distinct categories.
So instead of a number, we're predicting
Right.
a category. Give me an example.
Think about medical diagnoses. Doctors are using machine learning more and more these days to help figure out the likelihood of someone having a particular disease.
Wow. High stakes.
Right. They input all these factors, age, medical history, test results into a model, and logistic regression, it can analyze all that and predict. Is this patient likely to fall into the category of having the disease or not having the disease?
Powerful stuff. It's amazing to see how it's being used in all these different fields. So wow, we've covered a lot of ground. We talked about the importance of that solid math foundation, jumped into data science, Python libraries, all that good stuff. And now we've even explored how to make predictions using regression analysis. Whew.
It's been quite a journey. But, it's really just the tip of the iceberg when it comes to machine learning.
That's what's so exciting though, right? There's always more to learn. So to our listener out there, you came to us wondering, where do you even begin with machine learning? You provided that fantastic article by Mohammed El-Rafey, and hopefully we've shed some light on the key takeaways. But definitely go back and revisit that article with these fresh insights. You'll get even more out of it now. And as you continue on your machine learning journey, remember, this field is vast. It's constantly changing, which means there's always something new to discover. Stay curious, embrace the learning process, and most importantly, have fun with it.